Hello everyone, how are you all doing? I hope you're all doing good. Welcome back to the preparation of ISI with me. I had started मैं नंबर थ्योरी स्टार्ट किया था पता नहीं अंग्रेजी में बोलने लगता हूँ पूरा है ना। तो नंबर थ्योरी शुरू किए थे हम लोग। पहला सेशन आई होप आपको अच्छा लगा, कमेंट्स में बताना कैसे था। एंड या शुरू करते हैं ये वाला सेशन धूमधाम तरीके से। इसमें भी मैं कुछ चार चार सवाल लाया हूँ अच्छे अच्छे, गुड वंस। एंड yeah, those are very interesting actually. Okay, the first one, look at this. Maybe ये आपको पता होगा किस तरह से solve होता है. You know, again, whenever you have options, it is consider them multi-correct. Okay, consider them multi-correct. That is the new pattern. Hmm? Each question, even though it can be solved with using options, I won't solve it. Okay, this is true. I hope you have paused the video and tried it for yourself. I'm waiting for you to pause. Anyways, so it is true for A, B, and D. It is not true for 4. Maybe you can put some values because it has to be true for all integers. Use some integers, check for maybe 1 comma 1 comma 0 0 0 0. Then you can see that probably it is not true. All right, if M is 4. Now, what is the special thing about 2, 3, and 5? They are prime numbers. So this result is in general true for M equal to P, which is a prime number. Okay, and there is nothing special about the term 12. Um, so I would say x1 plus x2 plus till some xn whole power p is always congruent to x1 power p plus x2 power p till xn power p mod p. Okay, so this is a very interesting thing. Why does this happen? What is the proof of this? This is a basic statement. This is actual statement. So how do you prove this? How to prove? I will prove it using induction. Induction on what? Induction on n. Induction on n. All right. So if I take induction on n, that means it is true for n equal to 1. So let's say the base 1 is 2. N equal to 2 implies x1 plus x2 whole power p, that is equivalent to x1 power p plus pc1 into uh, x1 power p minus 1, x2, and so on till pcp minus 1 into x1, x2 power p minus 1 plus x2 power p. Now there is a thing which we will be using. There is something which we need to use. What is it? Hmm, p always divides pck, where k, whenever k is between 1 and p minus 1. All right, otherwise it is 1. So if k is 0 or p, it is 1. So p always divides this. I will leave that. I could leave that as homework, but I think the crux of the matter is you just write it. What is this? P into p minus 1 into till p minus k plus 1 divided by k into k minus 1 into till 3 into 2 into 1, right? Divided by k factor. Now you see p is a prime number. All of this has to divide all of this. All of this have to be cancelled out. Can any of the term from the denominator, can any term divide or cancel out p? If p is a prime number, this is prime. Can any of this cancel out p? P chale jayega. It is not possible, right? Since it is prime number, none of them are divisors of p. That means all of this will cancel out only till this part. So P will remain in the numerator. Numerator will have P. And we know that this is an integer. This is an integer, right? It's an integer. So P has to remain. So the thing is, this is the fact. Now we use this fact to prove this one. So for n equal to 2, this is true. So for n equal to 2, what happened is we have x1 plus x2 whole power p is equal to x1 power p plus x2 power p plus all that terms with p, c, k. K is varying from 1 to p minus 1. x1 power p minus k into x2 power p or k, right? So these things are there. All of this is divisible by p because of the previous proposition. So this is congruent to x1 power p plus x2 power p mod p. So this is true. Now we use induction on n. Let us say, so inductive step, inductive presumption. Say it is true for n equals to m, right? N equals to m. That implies that x1 plus x2 till xm whole power p is congruent to x1 power p plus till xm power p mod. So we are assuming this. So using this step, we move to the next step, which is for now. Let us look at n equals to m plus 1. What do we do? So we have x1 plus x2 till xm plus 1 whole power. Can I take this whole term as one single entity? Let's say this is s. So this can be written as s plus xm whole power p. Do you see what we are doing now? Now it has become something of two terms, which we have already done, n equal to 2, right? So this is congruent to s power p plus xm power p, right? We already proved. And what is s power p? This is congruent to this mod p, sorry. This is congruent to x1 plus x2 till xm whole power p plus xm plus 1. xm plus 1, I'm sorry. Whole power p mod p. Now what is this congruent to? Obviously this is, we proved it. The presumption. According to the inductive presumption, this is x1 power p plus x2 power p till xm power p plus xm plus 1 mod p. Therefore, what did we get? True for n equal to m plus 1. So n equal to m implies n equal to m plus 1. So this is true for all n belongs to this. So therefore, what did we prove finally is that x1 till xn whole power p is always congruent to x1 power p plus till xn power p mod p. Alright? Whenever p is prime. P is prime is being used to prove this part. This is the important part. I will highlight it. This is important. Okay. So that's about this question. So I hope you understood everything. For which prime pairs of prime numbers, is this equation true? All right. So for which prime numbers p and q is this true? You can pause the video, you can try to put in the values and check. Although I would not suggest for you to do that. I would always encourage you to please, you know, try to write it properly. Okay. Try to write the proper proof, especially when you're practicing. Don't try to use the options. This is only for you to have fun. So I hope you have paused the video and tried it. Only option A is true, and only that you could be able to check in. You can square this, you can square this, you can square this. Maybe you can maybe take till power 4 of this and add option D. Did you check? I don't know. I hope you have not, right? So this is kind of a different equation, right? So let us solve it. How do we solve it? See, there is one thing. Um, can this be ranged between two things? What is p square plus 1 whole square? P square plus 1 whole square is p power 4 plus 2p square plus 1. Okay. This is definitely less than the LHS, don't you think? Right? This is almost definitely less than the LHS. Why is this less than LHS? Mm, let's see. Let's see what happens. Okay. And what about p square plus p whole square? That is actually p power 4 plus 2p cube plus p square. Isn't this greater than LHS? Can you verify these two? That is a homework. So if you just take the subtraction, let's say LHS minus this, we will be cancelling. So 1 plus p square plus p cube plus p power 4 minus 1 plus 2p square plus p power 4. So it is 1 plus p minus p square plus p cube. So 1 is also cancelled. So this is definitely greater than 0. There is no problem. Okay. What about this minus LHS? Yeah? This expression minus LHS. So this expression minus LHS. So p power 4 plus 2p cube plus p square minus p power 4 plus p cube plus p square plus p plus 1. So p power 4 gets cancelled, 2p cube remains, so p cube, p square is cancelled, minus p minus 1. This is also definitely positive. So both are correct. Both are correct. You don't have any issues as of now. So we have that q square is between p square plus p whole square, p square plus 1 whole square. So we can actually say that q is between p square plus p and p square plus 1. So if you actually check, that means that q q is less than or equal to p square plus p minus 1, greater than or equal to p square plus 2. All right. So this is one thing. What else can we say about this? Look at it. If I do q square minus 1, right? So if I write q square minus 1, that will be equal to p plus p square plus p cube plus p power 4. I can take p common, p into 1 plus p square plus p cube. And this can be written as q minus 1 into q plus 1 is equal to p into something, 1 plus p plus p square plus p cube. All right. So p divides q minus 1 into q plus 1. That implies since p is a prime number, it cannot divide both. This implies that p either divides q minus 1 or p divides q plus 1. All right. If p divides q minus 1, so what is q minus 1? q minus 1, if you see from this one, q minus 1 is between p square plus 2 minus 1, right? And less than or equal to p square plus p minus 2. If you see carefully, can there be any multiple of p between these two? So between p square plus 1 to, so in the interval, at least I'll write it like this, in the interval p square plus 1 comma p square plus p minus 2. This is an interval of, what is the range, what is the length of this interval? This is at best p minus 2, right? There are 1 to p minus 2 number of terms. There is no multiple of, no multiple of p, right? Because it starts after a multiple of p, which is p square, and it ends before another multiple of p, which is p square plus p. So there is no multiple of p, so this is not possible. All right. Okay. So what happens when p divides p plus q, q plus 1? So that would imply p must divide q plus 1. What is q plus 1? Q plus 1 is between p plus 3, p square plus 3, p square plus 3 less than or equal to p square plus p, and that's it. P square plus p. Wow. Now we have a multiple, right? So in the interval p square plus 3 comma p square plus p, only multiple of p is p square plus p, obviously. So that means, that implies that q plus 1 is equal to p square plus p, right? So this is one thing, and that will imply q is equal to p square plus p minus 1. So we have this specific information. What do we do now? We substitute it in the original equation. That's what I want to do. So 1 plus p square plus p cube plus p power 4 is equal to p square plus p minus 1 whole square. What is this? This is p power 4 plus p square plus 1 plus p cube, okay, 2p cube minus p square minus p, right? Minus p square minus 2p square, 2p. So p power 4 cancel, p square cancel, 1 cancel. So what is left? We have 2p cube minus 2p square. Oh, p cube is also 1, p cube is cancelled. So you can get rid of one of that. P cube minus 2p square minus 3p equal to 0. That means p into p square minus 2p minus 3 equal to 0. So we have specific, we have something very specific. P into, I think this is p minus 3 into p plus 1 equal to 0. So only possibility is p equal to 3. So only p equal to 3, and that will give you q equal to 11. Right? Okay. So you got it. That's it. That's the solution. 3, 11 is the only solution. So this is a very beautiful question. Beautiful. Understood? Okay. So now that we are done with two good questions, I'll talk to you about this ISI batch, which we are going to start. Obviously, you know this, but I'm going to tell you the details briefly. It's going to start from 21st July. All right. And it is for classes 12th and 13th. 13 meaning the ones who have taken drop for any chance. And is, I totally appreciate it. If you want to spend 1 year and you want to enrich your life, no tabooing, nothing. Okay, come on, you can decide that for yourself. Chetan sir, the amazing Chetan sir, the Arthur Angel of US, he's going to take this batch completely. All right, what is the timings and all that? It will be from 3 p.m. to 4:30 p.m. 95 plus live sessions 3 times a week. All right, 3 times a week, Monday, Wednesday, and Friday. Chetan sir will be taking this. 20 practice tests will be there. See, the thing is, ISI ka syllabus is huge. It includes both the Olympiad syllabus along with your JEE syllabus. All right, so it has calculus, that there's everything. Number theory is also there, geometry is there, everything is there. All right, so it is a huge syllabus. It will be completed. It will be completed in around 100 live sessions. All right, you'll have a Telegram discussion. All that will be there. Every batch has this. You have a specific Telegram group where you can interact with the teachers, with the friends, with your own batchmates, and everyone. For technical queries, you have student academic mentors also for technical non-academic queries. Obviously, there are assignments after every session, monthly progress report, all these things are there. So I hope all that is known and understood. The batch price is this 12,999. After you use this coupon code, you'll get 10% discount. So that will be the price for you. And you'll be covering the whole syllabus in this batch, the whole ISI CMI syllabus, both the exams. And, in some sense, if you're preparing for ISI and CMI, you are preparing for whole of mathematics in general, because the syllabus is large and huge. It completes everything, and you are also preparing for subjective stuff. You are going to prepare for writing solutions. So, and Chetan sir obviously is going to teach in a level which you'll all be able to understand, and along with that, you'll be able to write the solutions for yourself. All right. So more things will be added to this batch. I think UGB sessions will be added later on. Maybe that's a secret. I'm not sure, but I'm letting you know. There is that possibility. All right. So that's it. Now let's solve two subjective questions, two questions which require you to write solutions. So let's start doing that. Okay, this is actually not that, it's also similar to what we solved so far. Okay, show that this implies this. What do we do? It also uses the same thing. I think as much as I understand this one, it uses the same thing. What does it use? It uses that P must divide PCK for K between 1 and P minus 1. This is what this is going to use. How? A is congruent to B plus A is congruent to B mod P power K, right? What does that do? That means A is going to be equal to, this will imply A is equal to B plus P power K into some M, right? And what are we interested in? We are interested in A power P and B power P. So what do we do here? I'll take A power P. So A power P is equal to B plus P power K M whole power P. And that is equal to B power P plus summation. I'll write here P C K P power K. So how do I write this? B power P minus K. Okay, K is already used. Maybe I'll use something else. L. P minus L. P power K M whole power L. L will vary from 1 to P. All right. And in all of this, you'll see that what is the last term? Maybe I'll take till P minus 1. And what is the last term? Last term will be PCP, which is 1 anyways. B won't be there. It is only P power K M whole power P. In other terms, you just see this. What is this? So B power P plus PC1 into B power P minus 1 into P power Km. What is the next term? PC2. P will be there. Regardless of whether P is there or not, this is P minus 2 P power Km whole square. Right? That means here there is already P plus P power K plus 1. P power 2K, definitely 2K will be greater than K plus 1 because taking K is greater than 1. Are we taking k is greater than 1? A positive integer. So let us assume k is greater than 1. All right. So even if k is not greater than 1, this will have k plus 1, right? P square is there. Okay. So what is happening? This is b power p plus p into, so here we have b power p minus 1, p power k plus 1, m, plus something which is p power k plus 1. So overall, all this is p power k plus 1 multiple. So definitely a power p is congruent to, this is the idea. You have to properly write it down. That's the idea. Congruent to p power p mod p power k plus 1. So that is it. That is it. The only thing which we need to, so subjective tip is that prove p divides pck, that thing. All right. Maybe you don't even need to prove that because you already have p power k, and so if you prove this is not needed to prove. That's just such a easy question in that sense. Why is that given as a subjective question? Anyways, let's go to the next question. Show that the system of congruences, this thing has solutions if and only if. Oh wow, these kind of questions are very good. What does it mean? If and only if means this implication is true, this implication is also true. Both have to be true. Got it? So let's first write down what is this implication. What is this implication? What do we need to prove? Given that x is congruent to a mod m, x is congruent to b mod n, right? These two are given. We need to prove m comma n, the GCD divides a minus b. That's easy actually. So x is congruent to a plus mk, let's say. Since x is congruent to a mod m, this will be true, and x is also equal to b plus nk, nl something. So that will imply a plus mk is equal to b plus nl. That will imply a minus b is equal to nl minus mk. Now this GCD thing, GCD m comma n divides n, and GCD m comma n divides m. Doesn't that imply GCD m comma n divides the RHS, a linear combination of m and n? So obviously m comma n divides a minus b. I think this is a very simple question, very simply stupid question. Anyway, if you take the other way around, that means m comma n divide a minus b. That will imply that there exists x such that x is congruent to a mod m. So this is two proof. This is the, and x is congruent to b mod n. Two proof. This is given. So how do you prove this? Here we'll use Bezout lemma. What is Bezout lemma? And subjective tip is that try to prove Bezout lemma. It's not hard also. So you need to know proofs and all that. They will test all these things. This is totally normal. So what does Bezout lemma tell us? That the GCD can be written as a linear combination of m and n, right? So that means my a minus b is equal to some multiple capital M multiple something L K L M N O P Q R S T alpha into mk1 plus nk2, because because m comma n divides A minus B, that will imply A minus B is equal to alpha into M comma N, right? So that's what I'm writing. So that implies A minus B is equal to alpha K1 into M plus alpha K2 into N. In other words, I can write A minus alpha K1 M is equal to B plus alpha K2 N. So let's say this term, this whole thing is equal to X. So if I take X mod M, that will be congruent to A, and X mod N, that will be congruent to B. So it is as simple as that. So such an M, such an X exists. So tip is prove Bezout lemma. So that will be your homework. Okay. So that's it for today. I hope you enjoyed the session. Take care. Tata. Bye bye.